So in our last lesson, we were learning all about REST services. And I suppose in theory now, you have enough information to write your own REST library. You could probably figure out in your language how to make a call over HTTP. You can remember to kind of take your access token and append it on to any call that, and you can use your JSON parser to get back that data and do fun things with it. But generally speaking, you shouldn't do that. Just about every major language out there has a library to deal with interacting with REST services, and they in general have dealt with all the difficult corner cases that you probably haven't dealt with yet. What happens if the network goes down? Or what happens if the token is no longer valid or has expired? How can we make sure we trap that information instead of, crashing? So you should definitely use these libraries. And typically they come in three types. The first type of library basically abstracts out all the networking bits. You still have to have a pretty good understanding of the REST calls you're going to make. This is an example from the PHP client library where we're just using the Google HTTP request method to take care of some of the networking details. But you'll notice I still have to supply the full address of the endpoint that we want. I have to specify that this is a post call, and I have to supply the values to this post call in an array. What this library does for me is it remembers the OAuth2 bearer token that I pass to it in an initialization step somewhere, and then it just kind of deals with making the call, getting the response, and returning it back in this bottom line here. So pretty low level, still kind of close to the metal. The second type of library takes advantage of something that Google does, and maybe other companies as well, which is we create this thing called a discovery document, which is a very, very detailed description of everything that goes on in our REST service. We have various tools that analyze our REST service, produce these very detailed discovery documents, and then within each of our languages, we have corresponding tools that read in this discovery document and essentially convert that into kind of native objects and calls that can be made within that language. This sounds kind of confusing and abstract, so let's just show you an example. This is the exact same call that I made on the previous slide. The big difference is this PHP library has a Google Game Service.php file that is generated by one of these tools. It's analyzed our REST service. It's realized that I have a scores/submit call that is a post that takes two values, the leaderboard ID and the score value, and basically turns that into a method that I can call directly. So I'm basically accessing this variable called Game Service, which is a Google Game Service object that then allows me to submit a score to a leaderboard just by calling a couple of public methods on it. I don't have to know that this is a post call, although I can probably guess. And thanks to the magic of code hinting, my IDE can probably tell me what values I should be supplying here. I don't need to look it up in the REST, call or the reference documentation and look up what the actual key is for each of these values or anything like that. It's nicely integrated. And then the third type of library is the, hey, let's completely abstract this stuff out for you. And this is what the Play Games library for iOS does. So here, I'm creating a score object by calling the GPGScore class method score with leaderboard ID. I'm assigning it a value, and then I'm sort of telling the scorer value, hey, go submit yourself. And here's a completion handler that you can call when you're all done submitting yourself. And in this completion handler, I'll have some information about the score I submitted, as well as any errors that need to be surfaced. And so you'll notice here, unlike the PHP library, I'm not even kicking off a network call. I'm sort of passing it on to the library to say, hey, start this up at an appropriate moment. And so what the library does is first it takes these tasks they want to perform and converts it into the appropriate REST calls. It also deals with all the networking auth junk for me. At some point, I had to initialize this with my GPP sign-in object, and you'll see that coming up. But then at that point, the library kind of takes care of managing my access token for me. I don't have to actually know my user's access token at any point. It does some smart things like intelligently cache data for me and deal with situations, for instance, where I'm offline. In this case, actually, I can still submit a score with completion handler, and if the user is offline, the library will be smart enough to hold on to that score and wait until I come back online again, and then it will attempt to submit the score in the background. What's even better is, by the way, if I submit a better score with the same leaderboard ID, the library will be smart enough to disregard this first score and just use the second one once I come back online. So there's a lot of extra logic that this library handles behind the scenes for me when it takes all this and converts it to REST calls, which is great. Except that it doesn't really do that. And I guess this is the big lie. I've been talking all about REST services. It turns out that right now, the Objective-C client library uses a completely different service called JSON RPC. And JSON RPC is another set of rules that can be used to talk to backend services. In some ways, it's similar to REST. In some ways, it's different. I think one of the biggest advantages of JSON RPC is that it's a little simpler to make batch calls all at once. On the other hand, I think with REST, it's easier to cache data you get back from a GET call and that sort of thing. And if you're wondering, hey, wait a minute, why did you just spend the last 10 minutes teaching me about REST when the client library does something different? The answer is that I would actually like you to forget this technicality and pretend that the Play Games library for iOS is also using REST behind the scenes. And there's a couple reasons for it. Number one, just about every other client library already uses REST. So Android, all of the server libraries, Java, PHP, Python, Ruby. And I'm pretty sure at some unspecified point in the future, we'll actually be changing things on the back end so that even the Objective-C library is using REST instead of JSON RPC. And frankly, this change should be completely transparent to you if you're using these libraries, which you should be for all the reasons we just went over. So for the sake of keeping things simple, let's just pretend that the Play Games library for iOS also uses REST in the back end. And if somebody wants to tell you otherwise, it's like that guy who tells you, hey, peanuts aren't really nuts, they're actually legumes. You know what? Shut up. They're nuts. Nobody cares. And the Objective-C library, it uses REST as far as I'm concerned. So now that we have a better handle on the games library and what it does underneath the hood, let's actually add it to our project. And we're going to do that in the next lesson.